All right, welcome back. This is Jacob, KC7WXD. So I've been playing a little bit more with this station monitor side tone generator for my tube transmitter and regenerative receiver. In the previous video, I had this design here, which was based on a design I found in an RF switch, like a transmit receive switch. And the issue that I was running into this is it was going to require me to basically run the output, the RF output from my transmitter into the monitor, and then kind of, loop back out to the antenna. And so that had I had some concerns with that. I didn't want to route everything through it. And really what I wanted is something that I can have like an inductive pickup, where just a little antenna nearby to pick up the RF, but not actually connected to the circuit. And that would help with input impedance matching, so I don't have anything weird going on. And so the old design was better suited for directly connecting everything up. So there's a voltage doubler in here, and then there's a zener that's in here to cap the voltage present at the gate on this FET to 10 volts. Because even at the lower wattages that I was doing, there would be 50 volts present, out of this doubler, because it's about 25 in, I was getting about 50 across this cap. That's too much. So this was capping it. I was playing around with sensitivity. I swapped out the diodes, these one in 4148s, which have a forward voltage drop of about 0.6 volts. I swapped those out for some, what are they? They're the germanium diodes, one in 34A, because those have about a 0.3-ish voltage drop. I thought maybe that'll increase sensitivity. I couldn't quite get it to work reliably, so started hunting around, and I found a better design. I did not invent this. I got this from Mike Murphy, WU2D, on his YouTube channel. I'll link to it below. And it's a little bit different. So it basically is doing exactly what I wanted, which is I got a little pickup antenna, so I'm not directly connected to the RF coming out of the transmitter. That's fed into a 0.01 microfarad cap. I have that germanium diode here for the rectification of that AC, the RF coming off. And there's a 470 microhenry inductor, 47K resistor. I didn't write this down, but this is a 0.01 microfarad, 0.001 microfarad cap. And this guy is a 2N3904. So the 2N3904 requires close to 0.7 volts to start conducting across the gate, or across the, this is the collector base emitter, to start conducting. And so playing with this, I have the scope hooked up, this guy right here. I have the scope hooked up basically right here, right at the base for the 2N3904. And you can see, here, I'll just kick this thing up. I'm getting about 715 millivolts, and look, that's lit up. So it works, and it actually works. Here, we'll flip this on. We got this light. I'll back this guy off a bit. It works pretty good. You just have to kind of get it close. But if you wrapped it around that, you would be even better. But well, there we go. This is the basis now that I'm going to use for making my little side tone generator. I'm not going to do it based off of a 555 timer, because I don't really like the square wave sound. So I found another design which generates a nice sine wave out of it, so it should have a better note for me. And we'll see how that goes. Okay, for the second part of this, I need to be able to spot myself. And so one of the issues you run into with regenerative receivers is that they overload really easy and they effectively block. So I can't, just like I can't use the transmitter as my own side tone, or sorry, the receiver to listen to my own transmitted signal to use as a side tone, I can't spot myself. So one of the ways you can dial in your receiver to what your transmitted signal is at is you need to have a real low power transmitter or an oscillator. And so I have one right here. This is a Pierce oscillator. The design, again, W2D. It's got great stuff. So it's a MPF 102 JFET, 20 puff cap here. In his design, he has this as a variable cap. I found for at least any of the bands that I care about, 20 puff seems to work just fine. I tried it with 40 meter and 20 meter crystals. 80 meter works fine too. Seems to work fine on 9 volts. I'd like to have this just run off of a 9-volt battery, which would be kind of handy. So right now I have this thing wired up at 7045 with a 7045 kilocycle crystal in it, and there we go. So we'll unplug, plug it back in. Okay, so what I'll do is I'll turn this guy down. I'll turn this guy up, and let's see if we can hear ourselves. There we are. So that is our own tone. So I'll unplug it and then plug it back in. There's the 0 beat right in here. Then we can pick the lower or the upper side of it so we can actually hear it. But it seems to work. And it's a lot more simple design as far as an oscillator goes than the one that I was looking at doing. So this just worked great. And fun fact, you can see the oscillation from the regen on this thing. Let me turn this off so you can see a little bit better. It's this guy up here. So watch as I tune up and down. So we can get it close. It sounds scratchy now because I haven't played with any of this on here, but yeah, this little oscillator works great. So we got 2 out of 3 components of this thing. Man, that 7300 sounds a lot better than this thing, but it's all right. So 2 out of 3, I got my oscillator stage here. I have this nice little low power RF detector that I can use to feed my little side tone generator. So I think next up is to build my little the side tone generator that gets triggered over RF. And then when all that is done, we're gonna solder this all up. I'm gonna try Manhattan style construction after this. So until next time, this is KC7WXT.